Hello. In this lesson, we're going to talk about the aspects of quadratics. So what are the aspects of quadratics? Well, first we're going to talk about the sketching of the function, okay? Even though that we can get the curve at our fingertips, but I'd like to go over some of the aspects of the quadratics because this will relate to how do you read the graph, right? How do you identify input from how do you identify output from input, and also how to identify output from input, right? So that will be the if statements. And also we're going to talk about other if statements, right? So these include the aspects of quadratics that we include from input to output. Okay, one is from input, how we get to output. Okay, and the other aspect is how to, from output, from output. Okay, how do we find input? Okay, so this is the two different aspects that we're going to talk about. Quadratic, okay? And along the way, right, we talk about the sketching. Okay, sketching will help us to read the curve better. Okay, well, in the lessons last time, we talked about how to do the, completing a square. Completing a square will help us to identify the vertex of quadratic functions. And identifying these vertex has a lot of very good applications in other fields, okay, such as business applications and the various others, okay? So I'm going to take the first example to address all of these different aspects. Okay, so the first example number 1. Okay, we are given a quadratic function, which is x squared plus 2x minus 3. Okay, quadratic. And for this function, of course, we can identify domain very easily, right? Domain is always all real numbers, right? Because this is a special case, a polynomial. This is a special case of polynomial. Now, the range is oftentimes a little bit difficult to identify. Okay, why? Because we know that this is a parabola. As a parabola, and of course, we know this opens up. Okay, so the range is to be determined. We need to find the lowest point, right? So we know this is a parabola, and this parabola has a lowest point, right? So we know a equals to 1, and it's a positive, right? So parabola opens up. Parabola opens up. So it has the lowest point. Okay, and this lowest point, we call it HK. In fact, this H and K is actually the H here. So this H is the same as this H in the completed square form, and the K is the same. And in fact, the vertex is H and K. What is the meaning of H and K? Right? What's the meaning of H and K? The meaning of HK is basically telling us that when input H, okay, X is H, okay, the output, right? So input, when input is H, the output, okay, when input X is X and X is H, the output is f of H, and f of H is K, okay? What does this mean? This means that when X equals to H, when input is H, the function reaches its minimum in this case. Okay, so this is the minimum value. This is the minimum value of the function. It's also the minimum output, okay? So just keep going. You may not completely understand this, but you're gonna understand it better as we're keep going, okay? Now, because we just have input output, right? We just have input output. And since this parabola opens up, So what are we gonna do is, because our goal here is to sketch, okay? And along the way, we're gonna explore from input to output or from output to input, right? Now, the first thing we can find easily, we always start from easy, right? We always start from easy. So we know it opens up, okay? It opens up, we'll answer that question. So next, the next easier thing to do is to find the Y-intercept. Y-intercept. Okay, what is Y-intercept? Y-intercept is when the input is given and the input is 0. So when input, okay, when the input X is given and it is given as 0, that value of Y, okay? So in other words, f of 0, when input is 0, f of 0, okay, so we're gonna plug in X equals 0, right? X equals to 0, and replacing X by 0, and we get an output -3. We get an output equals -3. So together with input equals 0, output equals -3, this makes a point. This is a point on the curve. But this is not any point. It is a point on the axis for the output, or Y-axis, okay? It's on Y-axis. Okay, so we're gonna plot that point. We're gonna plot that point, okay? Now, so suppose we have a blank rectangular system. Okay, we have a blank rectangular system. Okay, so I'm just going to set it up. Okay, so rectangular system is being set up. And we try to make it to be, the points is being marked, right? And you can see this point has a place. This point has a place. And this place, we call it Y-intercept. Y-intercept. So I'm going to use a red dot to mark it. Red dot to mark it. And this point is 0, -3. 0, -3. So please mark it on your notebook. Okay, so I'm going to do the same and mark it. And what we need to understand, the meaning of this point is that when the input is 0, the output is -3. Okay, because we only have input and output in our consideration, right? It's just, that's the nature of the question. Okay, so 0, -3. Now the question is that we actually don't know at this point. At this point, we do not know if the curve, we know this curve is going to pass this point, but we don't know if it's going to pass it this way. Well, we don't know whether it's going to pass it the other way. We don't know. Okay, so we need to know the vertex, the lowest point, right? We don't know where it is. So we just know one point on the curve. Okay, that is Y-intercept, right? You can see finding Y-intercept is the easiest thing to do. It's very easy to do. So we always start to do the simplest thing possible. Okay, the easiest thing to do. The next one, the next step we can do, okay, we can actually find another point. We can actually find another point on this line, on this horizontal line, actually, because we know that this, most likely this is, most likely this may not be the vertex. Okay, this may not be the vertex, right? We kind of guess it could be going this way or that way. But if we use our completing square technique, which is often used, and we can identify the vertex much faster, right? So we're going to use that technique. Okay, so then we're going to find vertex. So using the algebraic method we talked about from last lesson is to identify the vertex. Okay, identify the vertex. In other words, we're going to identify the H and K. Okay, so we got this, and we want to make a perfect square, right? So this is x squared plus 2x, so I'm going to add a 1, subtract 1. And this operation add a 0, anything at 0 stay the same. So according to our mathematical principle, this is not going to change, you know, that this expression is the same as a latter expression, right? So we want to make sure, right? The first adding 1 is to make the perfect square. Okay, this will make a perfect square. And subtracting 1 here is to make the balance, right? To guarantee the first expression is still the same as the second as the third. Okay, now as we regroup these, and of course this piece is equals to a perfect square, which is x plus 1 squared. -1 minus 3, that's make -4. So we got this perfect square. As you can see, from this perfect square, okay, don't underestimate this importance of this completing square, because even when you're in calculus class, you might still need to use this technique. You might still need to use this technique. What's so good about it? What's so good about it is that because this piece has a minimum value of 0, okay, it can be 0. So when this piece reaches its minimum, okay, so we have the perfect square, right? We have the perfect square in our quadratic expression. In comparison with this expression, we have found, right? We have found our H and K. We have found our H and K. Okay, so how do we identify our H and K? Well, A is equals to 1. We already know that, right? So A is 1. X matches X. H matches negative h matches 1, so to speak, okay? So h equals to -1, k equals to -4. Okay, so if you look at this expression, okay, I'm going to put a note here. The minimum value, okay, of x plus 1 squared is greater than or equals to 0. As a result, f of x, okay, will be at least 0 minus 4. So the minimum value of the function is going to be -4. Okay, so this tells us, and this also tells us when x plus 1 squared is equal to 0, the minimum value is achieved. So that's what we just talked about, you know, in here, in more in a, you know, abstract form, right? So with that note, we're going to give you some examples, right? Give you some examples. Say for h equals to 1, for example, if you plug in, right? If you plug in x equals to -1 and x equals to -1, and you get -4. If you plug in any other value, if you plug in any other value for the domain, the input can be any real number. If you plug in any other value, you're going to get a value larger than -4. So -4 is the minimum of the output we can get. Okay, so input, output. So this form, this quadratic form with a complete square in it, give us a lot of an advantage. It tells us when the minimum is achieved, or in some other cases, when the maximum is achieved, right? That would be the case when the parabola opens down. Okay, so for example, suppose you plug in 2, f of 2, right? If you plug in f of 2, right? You plug in f of 2, and this is going to have 2 plus 1. And if you evaluate this numerically, you're going to have 5. 5 is larger than -4, right? If you plug in, say, I'm going to plug in -5, doesn't matter. So this is going to be -5. And then you evaluate it, you get 12. 12 is larger than -4. So if you keep going, no matter what other number you plug in, other than -1, I guarantee you that -4 is going to be smaller than all of them. Okay, only when you plug in -1, you reaches its minimum. So that's what it means. So what's the meaning in graph, right? So now we found the vertex. Now we found the vertex, right? The vertex is -1, -4. So I'm gonna take this picture, which we did, right? We just had a 1 point before. Now we have one more point. And we're gonna put this number in the picture as a red dot. There you go. So now, before we didn't know which curve, you know, we're getting. Now we are certain the curve is going to be like this. And this is the lowest point. Okay, this is the lowest point. Hold on. And we're going to mark it. Okay, so let's mark that lowest point. That lowest point is -1, -4. Okay, and so let me put it as -1. So we're going to mark that point on the graph. So we're in the process of sketching. So every single point you get, we're sketching. We're not trying to get a precise value, really. We're not trying to get a perfect curve, right? So this process aims at helping us to identify points when we actually see a curve. What's so important about it, right? The y-intercept is important. The vertex is important, right? What's the meaning of the vertex? And then we can pretty much certain that the curve is going to be, it's going to be coming, the curve is going to be going this way and coming back up. And the other thing we know is that because we know it's a parabola, it's going to have a line of symmetry, right? The curve is going to be symmetrical. What kind of line of symmetry here? We can also tell the line of symmetry is going to be like this. Okay, so I'm going to draw that broken line in the picture with this software here. So we also have identified the line of symmetry. Okay, the line of symmetry, we know that the curve is symmetrical with respect to this vertical line. What is the equation of this vertical line? The equation of this vertical line is, so you can see along the way, we actually reviewed a lot of information. Okay, x equals to -1. Okay, so I'm going to put it right here to make that mark. The line of symmetry. If we know the line of symmetry, right? If we know the line of symmetry, which is x equals -1, this is the vertical line, right? So we know that this piece of curve and the other piece of curve is symmetrical, right? The next thing we want to find out is the x-intercepts. Okay, the next thing we want to find out is the x-intercepts. So how do we find x-intercepts? Regarding how many x-intercepts do we expect? In this case, we actually expect there should be 2 x-intercepts. How do we know that? Because we know the parabola opens up and the vertex is beneath x-axis. So when the curve going up is going to cross the x-axis. So in this case, we have 2 x-intercepts. Are there cases that we have no x-intercepts or less than 2 x-intercepts? The answer is yes. Okay, so we will have those situations. We have less than 2 x-intercepts, but there are only 3 cases. We either have 2 x-intercepts or 1 x-intercepts or no x-intercepts. Okay, then you wonder, do we have to go this far to determine? The answer is not necessarily. We actually have a shorter way or easier way to determine this, right? But because the purpose of this sketching is for us to be more detail oriented. So that's what we are doing here, and also going over the concept. So x-intercepts. So what's the meaning of x-intercepts, right? So by this time, we already have this function it's in 2 forms. Okay, so by this time, we already have the function in 2 forms. This is one form, and we have the other form, right? So we have lots of information at our disposal. Okay, right here, right? So this basically tells us the left is right. They're the same thing. It's just a different look, right? So the intention to find x-intercept is to see where the curve crosses x-axis. Since we have determined there are going to be 2 of them, right? So we can find the crossing in 2 different ways. I'm going to show you to find the crossing in 2 different ways. Okay, the first way is that we can use this form with a completed square, okay, to identify the x-intercepts. And the other way is we can just use a quadratic formula, okay? But let's first make sure we understand what is the meaning of x-intercept. X-intercept basically is telling us that we want to find the we want to identify the input. Whoops. Okay. We want to identify the input such that the output is 0. That's the meaning of X-intercept. In other words, we know that, say if we use this one, right? We use this form, you set it equal to 0. This is the so-called, you might have to remember, right? Setting y equals to 0. Setting y equals 0. But setting y equals 0 really is telling us the output is 0. So we know the output, right? So I hope you make a connection to what we done before. So we're setting y equals 0 to determine x. Excuse me. Determine the x values. Determine the x values. Okay, and we may have multiple solutions. Excuse me. Okay, so we end up solving for x from here. Okay, so now we're going to say, here we say solve for x. Right, so solving for x from this equation, and then the step is pretty straightforward, right? We just have x plus 1 squared equals to 4. We add 4 on both sides, right? And then we're going to take square root on both sides. Square root of 4 is 2. Square root of 4 is 2, right? And then what? The left-hand side is going to be the absolute value. Okay, the left-hand side is going to be the absolute value of x plus 1 equals to 2. And this should remind you of the absolute value equation we did, right? The absolute value equation we did. Okay, so this is one of the methods. I would say method 1 to find X-intercepts. Okay, and then when we were solving absolute value equation, we know that this leads us to x plus 1 equals to plus 2 or minus 2. Okay, that is, right, x plus 1 equals to negative 2 or x plus 1 equals to positive 2. And of course, here we got 2 solutions. So we get negative 3 for x or right, x equals positive 1. Okay, what does that mean? Well, this tells us we have 2 X-intercepts. So we found our X-intercepts, right? Intercepts are points. We have 2 points. These 2 points, one has the x coordinate equals negative 1. What is the output? The output is 0 because we got x value by setting y equals 0. So these 2 points have the same y coordinates. In other words, they're on the same level. It's a horizontal cut, right? It's a horizontal cut. Remember, we talked about when the output is a given, that's a horizontal cut of the curve. So now we got the 2 points on the curve, and we can put these 2 points on the picture, So let's do that. Okay, so first point, that's a red dot, right? Second point, that's a red dot. So get 2 dots, right? So let's mark these 2 dots. Let's mark these 2 dots. Okay, so one of the dot is negative 3, 0, right? So I'm going to put it at a 0.25. No, sorry. I should put a negative 3, 0.25. Marking these points. Right, that's 1 point, right? And the other point is 1,0. So here's 1 and 0.25. And we're going to mark these 2 points on our picture. Mark these 2 points on our picture. Okay, so we've got these points, right? For sketching, usually these points are sufficient. You just connect the dots. So now we're going to connect the dots. Okay, we can connect the dots. Connecting the dots, we basically graph the function, right? And we got the curve. We got the curve. So that's a sketching. That's called a sketching. But once we get an X-intercept, there's some other interesting phenomena. And also at this point, actually even earlier, we can also tell the range, right? We can tell the range of the function already from the vertex. Okay, the range of the function is from where? The vertical span, right? From -4, right? The range for the function would be from -4, right? All the way up to infinity. So that tells us the range all the way to infinity. So we can tell the range of the function. Domain range is answered along the process, right? So domain is unanswered range is from, I'm going to give you a variety of ways to expressing the range, okay? It's -4 to infinity. This is probably something you have seen before. It's useful, but it's not the most useful. So what are the most useful? Okay, I like to give you the most useful form. Okay, that form would be f of x. That output is at least -4. This first form is most useful. Okay, you can also just put the function in place, right? So x squared plus 2x minus 3 is larger than or equal to -4. What does that mean? What does this mean, right? The meaning okay? The meaning is saying that for any input, the function, right? It can be any real number, right? That's the domain. The output, f of x, will never be smaller than -4. So the output is always greater than or equals to -4. And curve-wise, on the curve, it says what? It says no point will produce an output smaller than -4. And you can see from these vertical lines, right? So you see for this input, the output is this negative, but it's still larger than -4. For this input, right, the output is this much. It's a negative, but because it's beneath x-axis, but still larger than -4. And this input, the output is larger than -4, right? So all of these inputs and outputs, okay? So for this input, and that's the output. All the output, all these red heights, right, of the outputs, they are all outputs. It also tells us something else, right? It tells us that this piece of curve, right, from -3, 0, all the way up, right? That piece is actually positive piece. All the output is positive. All the output is positive. And this piece underneath, those are negative piece. Okay, those are negative pieces. Let me clean it up, right? And mark it again. So this piece is a positive, and that piece is a positive. and this piece is a negative, and at the two dots on the x-axis, and those are the outputs, those outputs are 0. Okay, so output positive on this piece, output positive on this piece, output negative on this piece, right? And input and output is 0, right? Output is 0. So this is how you read the picture. This is how you read the picture. Of course, there's much more to it. There's much more to it. It also tells us when the output is negative. So when our input, okay, when our input, you see there's so much details, right? A picture tells 1,000 words. When the input is between -3 and 1, the output is negative. When the input is less than -3, is positive. When input is larger than 1, it's a positive, right? There's so much information about it. So we're going to get to those. We're going to get to those, okay? If you understand the picture thoroughly, if you understand this picture thoroughly from the function's perspective, from input-output relationship, no question will be too difficult for you. No question will be difficult for you. Okay, so we're going to get to it. Okay, so you're going to see the details. So now we got the sketch, right? And next we're going to we make some narratives, right? We have talked about the maximum, minimum, and we have drawn the line of symmetry, right? The line of symmetry. And the equation of the line of symmetry is also drawn, x equals -1. All of these are marked. And next example, we're going to do a couple of examples to work on the notation. Notation, we understand, is very, very important. It's very important to understand these notation. If we don't understand notation, you know, anybody would be totally lost. When I'm speaking for myself, okay, I'm speaking for myself. Okay, sometimes in your study, you might see these notations, say f of 1, right? F of 1, right? This is 1, right? They will tell you evaluate f of 1. And another question, they will ask you to. Another question, they will say, find x such that f of x, f of x equals 1. What's the difference between these two questions? What is the difference between these two questions? To illustrate the difference between these two questions, I'm going to make a table. I'm going to use a table to explain this. Okay, what is the meaning of evaluate, right? Evaluate. And these questions is not alone to quadratic. Right? It's not alone to quadratic. You see this with any function. It just rules are different, right? So find x such that f of x equals 1. Some of you may know the difference, but here I still want to emphasize the difference. In the first situation, the input is given. So input is given. Okay, the input is given. In the first case, input is 1 is given. We're looking for the output. So f of 1 is the output. So the first question is asking for the output. The second question is that we know the output. You see, it tells us f of x is the output. The output is given. The output is 1. You can see that's fundamentally different. Okay, so in the first case, we don't know the output. We're looking for output, but we were given the input. So remember the definition of functions, right? For each input, there's exactly one output, right? But in the second case, that we're looking for all possible inputs such that the output is that one given value. And graphically, on graph, you'll see this pictures. Okay, you're going to see these two pictures. And one picture is drawing the horizontal line, and the other picture is drawing a vertical line. Let's see which one is drawing the vertical line, which one is drawing the horizontal line. Okay, it's because X is a given, input is a given, right? So let me make it here. Right? Since the input is a given, that basically means X equals to 1 is a given. So we're going to draw a vertical line. And this one, the output is a given. That's the so-called Y is a given, or f of X is a given. Okay, so this is basically commonly used is Y equals to 1, right? But here in our context, I actually did not introduce Y anywhere. I actually didn't, right? So I did that on purpose because I want you guys to get used to these function notations. Since one, so that's why when you introduce Y, you have to tell the reader Y is f of X. So this is the meaning of this one is saying Y is what f of X. That tells the reader Y is the output, right? So let's draw the vertical line. Okay, let's draw the vertical line. Right, let's draw the vertical line. And the vertical line crosses the curve and there's a crossing. And of course, we already know the output, right? And the other one, the meaning, the geometric meaning is that we're going to draw a horizontal line. And that's the horizontal line. You see, that's a horizontal line. So we're trying to identify these 2 points, right? These 2 points. We don't know the input, and we're looking for the inputs such that the output is 1. Okay, so both input, right? We don't know what they are, and we're going to find it. So that's the difference in the meaning. Okay, so with that understanding, so let's find them. So this perspective is very, very important. So you don't get confused. I see so much confusion. So with that understanding, let's go find f of X, right? We had a summary about our functions, right? So this is our function, and we have 2 forms, right? I want to bring the 2 forms with us. Where did I put it? Where did I put the 2 forms together? No big deal. I actually know them. Okay, but what I want to show you is that with that 2 form, you can use either one. You really can use either one. So I'm going to take these 2 forms and carry out these operations. Okay, and of course we have another form. I don't want to forget that. Because these 2 forms, we work so hard to get, right? We got to use them sometime, because sometimes you find it is sometimes it's useful here, sometimes it's useful differently, right? And one thing I haven't talked about is that I talk about method 1 to find X-intercept, right? I will talk about method 2 after we're done with these. Okay, now, so f of 1, you can use either form. So if you use the first form, so f of 1, you can just plug in because you know the input and you know the geometric meanings of it, which is just a vertical line, and you just evaluate, you get 0, right? Of course, we already know the answer. And the second question, right? For the second question, right? What you do is you can use this one. You can set up this guy equals to 1, right? Because f of x equals 1, but you can also use this guy. You know what I mean? Because they're the same. You can use this guy. Why not? Why not? You see, because we know they are the same. You can use either one, okay? I will show you the advantage of knowing, of using the second one that we worked so hard to get, right? The second one, we get x plus 1 squared equals to 5, right? And then we will take square root on both sides. See, we take square root on both sides. We get root 5. I get root 5, right? And the left-hand side is going to be the absolute value of x plus 1, and the right-hand side is root 5. And this, does that look familiar? That's a typical of absolute value equation, right? So we get x plus 1 equals to plus or minus root 5. Okay, and what else do? We subtract 1 on both sides. So x equals to -1 plus or minus root 5. We got our 2 points. We got our 2 points. So what are these 2 points though, if we want to put it on the chart, right? We got to this point is already plotted, but we are curious about these 2 points, aren't we? We're curious about these 2 points, right? When we draw that horizontal line, right? Where does it cross, right? What's the coordinates of those 2 points? So these 2 points, what are they? Well, here they are. Okay, so we're gonna have 2 points. These 2 points, one is -1 minus root 5, and the other one is -1 plus root 5, and they have the same output. The same output is 1. Okay, so I'm going to mark these 2 points on the graph. Okay, we're going to mark those 2 points on the graph. And there you go. These are the 2 points. And which is which? Which is which? Okay, I'm just going to use, so this point is that one, and that point is this one. Different inputs, same output. Different inputs, same output. I hope these geometric interpretation will help you to understand, right? You see, we're still working with input output, but this time from output, we're finding input, right? So these are 2 different types of questions. And the notation is very clear. We just have to understand what it is, right? The notation cannot be ambiguous, and the mathematical notation has always been very, very clear. Okay, if you don't understand, you want to make sure you get to understand the meaning of the notation. You must. All right, so without further ado, so this is the question, right? This is the question. Okay, and let's do another pair. Let's do another pair to understand these notation. Okay, you may like to try this with me, right? So I'm going to tweak the question a little bit, right? If you want to pause the video and do it. If you want to pause the video, do it. So, okay. So the answer, I'm going to ask this, since we're going to complete this before we right, we talk about the geometric meaning, and we got it that f of 1 equals to 0, right? So we talk about the setup, right? F of 1 is 0. And this other one, we set f of x equals to 1. Right? So we have the different setup. Okay, I'm also going to say, okay, how about I set up the other way? Of course you can. Okay. Of course you can. You can set up the other way. No problem. And the solution, right? The solution, we're going to put it in the chart, right? And this solution, the vertical card, the solution, there's only 1 point, right? Because for each input, there's exactly 1 output. We don't have more output, right? It's 1, 0. And the other one, right? In this case, we have 2 solutions. We have 2 solutions right there. Okay, so now I can replace this picture by what we did earlier. You see? So one is a vertical cut and the other one is horizontal cut. Okay, so vertical cut. Okay, so let me even mark the vertical line, right? The vertical line actually is given to you. Okay, that vertical line and that's the horizontal line. So let me just point it to them. You know what? I think I'm going to write on it. Okay, so I'm going to write on the graph. And I want you guys to do the same. Take your time and really understand which one I'm marking. Okay, this one. Okay, so I'm going to mark x equals to 1. Right, so this is the vertical line we're marking. And the place we're going to put it here. So you can wait. Okay, it didn't finish. Okay, so x equals to 1. So this line is marked. X equals to 1. Y equals to okay, so that's the vertical line for x equals to 1, and the other one is a horizontal line. Okay, horizontal line, which is y equals to 1, right? Y equals to 1, we're going to mark it. Where are we going to mark it? Okay, I'm going to have to move this over. Okay, I'm going to move this over to determine the place. So I want you guys to take the time to mark it as well. Y equals to 1. So you know what to look for, right? So this is y equals to 1. You can see the equation are different, right? There's a vertical line for the vertical cut, horizontal line for horizontal cut, right? I hope this doesn't confuse people. I should move this y equals to 1 over. Okay, I'm going to move it over. Y equals to 1. Okay, y equals to 1. Move it over. I can move it over to this side. Okay, so 2.5. Okay, that should do better. Okay, so this is the horizontal line, right? So you can see vertical cut, horizontal cut. So what do we have other cuts? In terms of input output, we don't have other cuts. So next, what I'd like you guys to practice, okay? I'm going to change this question, similar questions, okay? So you can practice in class right here, right now. Okay, so let's see what I'm going to change, right? I'm going to ask you to evaluate f of 2, and the output is 2. So this is 2, and that is 2. You see? So x will be 2, and that's going to be 2, right? So you're going to have to redo all of these things. You're going to have to redo all of these things. Everything changed to 2. So you're going to have to add those vertical line, horizontal line to the picture. Okay, I would just go forward. I would just go forward. Wait, okay, so these point is to be found, and these points are to be found, and the output is going to be 2 instead, right? And this answer is going to be 2 comma something, right? Question mark, and over here is going to be 2. So I want you to take your time to draw the picture, maybe pause the video. Okay, pause the video. Okay, and then come back and come back. Okay, actually, I'm going to pause it. And of course, I'll come back. Now just get something to drink. I'll be right back. All right, I think you're probably back. Okay. You can see that once you understand the notation, you understand the inner working of all of these graphs. It's pretty straightforward. Input, output, given input, find output, given output, find input, right? Do we have any other types of questions? No, unfortunately, no. Okay, most of the time it's just these 2 types. Okay. All right, so have you found your solution? Have you found your solution? Okay, so let's go for it. Let's go for it, right? So f of 2, right? You can use any form you want, right? We have 2 forms of the function and they're the same. So for f of 2, okay, I think I'm behind you, right? But that's okay. I'm glad you're ahead of me. And you just evaluate and write. So f of 2 is 5. So f of 2 is 5. You can just plug in, right? So what are the inputs such that the output is 2, right? You're going to draw the horizontal line. And here you're going to draw the vertical line. So let's draw the vertical line here. Why not? Right? So we're going to draw the vertical line in this picture, right? Oops. Okay, vertical line. There we go. X equals to 2, right? And I can even mark it. It gets a little crowded. It gets a little crowded, okay? So that's X equals to 2. So that's going to be 2.1 and negative 4.75. You don't have to worry about I put those points there because those just how to use the software. Mainly, I want to show you these vertical line and there's a crossing here, right? So the point of intersection, right? The point of intersection is 2,5. 2,5. So I'm going to put a red dot right there. 2,5. Okay, so you can put the 2,5 there. I wonder if I have space. Okay, I can make space. As we're doing this, I would like you to reflect, right? To reflect on the meaning of these things, right? Input, output, you have a rule, you have input, you have output, right? So it's going to be, let's just use 2 and that should make it. That should make it, right? Just mark those points. And there we go, 2,5, right? 2,5. And on the other one, right? On this other one, we're going to have to draw the horizontal line, but first let's solve them, right? So let's solve it equals to 2, right? So for f of x equals to 2, right? You see, it tells us, right? There's no need to be confused because it tells us f of x equals to 2, and this is f of x, right? And this tells us f of x is 2, or we can say if the output is 2, right? That's the if statement, if you choose to read it that way. I think I would like to read it as an if statement, right? In mathematics, we either have statement or if statement, right? So now let's solve it, right? We can pretty much use the same technique to solve it all by adding 4 on both sides. So this equals to 6. And then we take square root on both sides, right? We take square root on both sides. You already know where we are heading, right? You know where we are heading. Square root, right? And on this side, it's kind of repetitive, right? Once you understand it, you understand the meaning. It just repeats certain steps. And of course here, we're getting x plus 1 equals to plus minus root 6. And we got 2 points, right? So what are these 2 points? Point 1, oh, hold on. So x is equals to -1 plus minus root 6, right? So what are these 2 points we have? Right here, right? -6, minus root 6, and the other one is plus root 6, right? And these are the inputs, and the output are 2. They share the same output. Now we can put the points on the dots. We can put the dots on the graph, right? So I'm going to put the dots on the graph. They're going to be red dot, okay, 1 by 1. There we go. And that, of course, the consequence of drawing the horizontal line y equals to 2. Boom, right there, right? And we can mark the points. And now the answer, right, is 2. The output is 2. The output is 2. The output is, oh, wait, am I marking them on the wrong place? Yes, I marked them on the wrong place. No problem, no problem. Okay, you know what? It just, no problem. So this is 5. I'm gonna keep that. I just changed the picture, right? I just put this picture under, right? And put this picture, okay, here, right? And I'll just put the other picture in my other, right here. Okay, no problem. We got it. We got it. So this will be y equals to 2, right? So by this time, I think you guys understand everything already. And I just need to put these 2 points in the picture. Okay, I'm not going to mark it because they're already crowded. They're already crowded. So I'm going to use arrow to point it out. Okay, I'm going to use arrow to point it out right here. So for y equals to 2, I'm going to mark y equals to 2. Okay, hold on. I need to see the picture. Okay, I need to see the picture. So I'll move it over. I'm going to mark y equals to 2. You see the similarity, right? You see the similarity. So here we're going to have 2. And that's going to be 3. 2.75. It should work. There you go. Y equals 2. Too high. Too high. Okay. But you know what I meant, right? You know what I meant. I just need to bring it down a little bit. And make this 2.25. There you go, right? So so for these two types of questions, if you know how to do it, perfect. Okay, perfect. So that's the meaning, interpretation, right? And we're gonna do one more. We're gonna do one more. Vertical cut, horizontal cut. Okay. And this time I'm gonna choose something okay, I'm gonna copy this table. Okay, but this time we're gonna introduce something else. Still gonna do vertical cut and horizontal cut. Okay, I'm gonna do vertical cut and horizontal cut. But this time I'm choosing values. And these values I'm gonna choose. One is -1. No, wait, sorry, not -1. I would choose -5 for input. And the output is gonna be -5. Okay, so I want to show you what will happen if this is the case, what to expect, right? So the input is -5. I'm going to draw a vertical line. And this is output is -5. Output is -5, right? So we're going to draw those vertical lines. Just hold on, okay? And of course, this is going to be -5. And this is going to be -5, right? We don't know what's the output yet. Question mark, right? We haven't drawn the line yet. And over here, the output is -5. The output is -5. The output is -5 here. Okay, if you would follow me, we don't know the input yet. We don't know what input will give us output -5. Okay, I really want you to think about this. But when we draw those vertical line, right, it looks like I have to, in this picture, I have to make it just a little wider on the view. Okay, so I'm gonna make it to -6, right? And vertically, I also have to make some adjustments, say make it 10. Okay, so I'm going to draw that vertical line. I'm going to draw that vertical line. So first, and you do it along my side, okay? Do it along my side. So this is the vertical line I'm drawing. And there you go. It looks like there's going to be a crossing. Of course there's a crossing, right? Why? I know for sure there's a crossing because every input, there's exactly one output. Function definition, we know this is a function, right? And the domain for this function is all real numbers. So every real number has exactly one output. So I have no doubt. It's just whether the pictures show it or not, right? So if it doesn't show it, I just have to make adjustment. So I'm going to just do a little bit more. And here we go. So I'm going to just make that adjustment so that it will show me. It will show me. It has to. I'm going to make it show me, right? I know there's a point. I know there's a point, and that point can be found, right? So I'm just going to plug in. I can plug in either one of the form, right? So this is -5. And -5 plus 1, that's -4. -4 squared is 16. 16 minus 4, 16 minus 4 is 12. So it's 5, negative 5, and output 12. So that point is found. That point is found. That red dot right there, right? So that's 5, negative 12, negative 5, 12, sorry. Negative 5, 12 is right here, this point. On the other side, I'm drawing a horizontal line, which is y equals to negative 5. You guys know it, right? We've done 2 examples, right? We're going to draw y equals to negative 5. So I am going to draw y equals to negative 5. Okay, this horizontal line. It barely shows, right? So I'm going to make some adjustment. I'm going to make some adjustments. So I'm drawing this horizontal line. What do you see? The curve does not touch the horizontal line we just drew. What does that tell us? What does that tell us? When will the output be negative 5? The answer is never. No solution. No solution. So in this case, actually, there's no solution. There is no solution. Okay, so you can see the visual sometimes give us a lot of advantage. And of course, we're going to see the algebraic. We're going to see the algebraic, but the visual, right? Because after all, you're dealing with these functions. You just sometimes you draw a vertical line, sometimes you draw a horizontal line, right? Horizontal line tells you something, vertical line tells you something. So that's all. And not only these things we're going over here is for quadratic, it's for any function. It is true for any function, okay? So I hope that these discussions will help you to understand a lot of phenomena, and including the notation about the meanings of mathematics, right? I hope it becomes more concrete and makes sense, right? Makes sense. No solution. No solution. In other words, there's no touch, no solution. Right? Touching means there are solutions there, right? There's the crossing, right? The crossings are solutions. No touch, no solution, right? No touch, no solution in this case, because we want the output to be negative 5, and then that will never happen. But let's see what will happen algebraically, right? What will happen algebraically? Okay. And of course, in this case, you draw your conclusion, but sometimes you set up, you may not have the convenience to draw the graph, or the graph is not accessible to you. So algebraically, it also tells us the same information. We just have to know how to read it, right? Suppose we solve for x, right? We know that's what we need to do, right? And what will happen is that we're dealing with this familiar equation, right? So we add 4 on both sides, so we have negative 1. If we take square root on both sides, what will happen on the right-hand side? Yes, we are going to encounter I, that imaginary number. So this is I. Okay, this is I. Right? The I in mathematics, it certainly is not the same for iPhone or iPad, right? This I really just represents this number. It's an imaginary number, okay? We can get 2 solutions, but those 2 solutions has no place on the graph. Okay, so you can go ahead. Sometimes you may need to find it, right? So you're gonna get x plus 1 equals to plus or minus I, right? So as a result, you're going to have x equals to -1 plus minus I. But these numbers have no spot in the picture. So we have two complex number solutions. Okay, complex number solutions. Two complex number solutions. Two complex number solution. What does that mean? This also tells us in the real number discussion, okay, this graph is all about real numbers. There's no solution, there's no real number solutions. No real number solution. I'm going to put no real number solutions, right? No real number solution. That means the curve does not touch the horizontal line we drew. So all of these corresponds to each other. If you see the graph give you something, then you know that you should not expect a real number solution. But sometimes you may have complex number solutions, okay? So there's no real number solution. So the graph tells us very well. And algebraically, you can find out about this as well, okay? So when you solve a quadratic equation and you encounter complex numbers, and this merely just tell you there's no real number solutions, there are two complex number solutions, and so on and so forth. Right? So horizontal line, vertical line. So we're pretty much done with the picture and its understanding. And next, so you see we're dealing with the given input, given output, right? So next we're going to look at a couple of inequalities, right? Because this lesson is about aspects. It's about aspects of quadratic, aspects of quadratic, right? So I'm going to bring what we have so far, right? We have these pictures, right? Horizontal line, vertical line, and so on and so forth. And the next thing we're going to do, we're going to look at another question. We're going to have a sequence of questions. The question number 1, okay, right, is solve for x such that f of x is larger than 0. X squared plus 2x minus 3. Okay, I'm going to make the fonts larger. Okay, sometimes these are omitted. Sometimes you don't see this. Okay, solve for x such that this is larger than 0. What does this mean? What does this mean? Function perspective, right? Whether we have that f of x or not, this should be regarded as a function. So whether you have this written up, right, assume the f of x is this or not, you should regard this as a function. And this function has a graph. We just did the graph, didn't we? We just did the graph. Where's our graph? Look at that. We got our graph. Okay, this is our graph. This one, let's just take this one, right? This one, it's pretty simple. We just take this, the simplest form of our graph. We have this information here, okay? We know some basic informations, right? We can use the other graph, but that's just a little too messy, and we don't really need them actually. Okay, we don't really need them. You understand why I choose this. Okay, so if this is a question, right, so how do we read this question? That's my question, right? My question is, how do we read this question, right? Oftentimes you might be given something like this. Solve for x such that f of x is larger than 0. What does it mean? Right? This means that identify all the inputs. Identify all the inputs such that the output are what? The output are positive. Positive output. So this is if statement again. If statement again. And what are the solutions? We actually just talk about it, right? Which piece of the curve tell us, which piece of the curve that tell us, right? The output are positive. Well, these two pieces. These two pieces. How about these two dots? Well, at the two dots, the output is 0. Well, we don't want 0. We want to be positive. Therefore, in this case, what do we do is that we're going to mark 2 circles on these 2 dots. Okay, we're going to mark 2 circles on these 2 dots. Okay, okay, so this is going to be a circle. Okay, you know what 2 circles means, right? They're not included. And how about this piece? So now we can look at this picture, right? We can look at this picture. This piece is a positive, and that piece is a positive. The nature of our question is, say, to identify, okay, identify all the inputs, right? That's what solving for X is for, right? Identify all the inputs such that the outputs are positive. That's the nature of the question, right? That's the nature of the question. So the nature of the question is to identify all the inputs, okay, all the inputs such that the outputs are positive. That's what it means. Identify all the inputs. So what are all the inputs? Well, obviously, where are they? They are here, all the way to the left from -3, not including -3, and all the way to the right from +1, not including +1. Okay, so let me graph those dots. Let me graph it and show it to you. Okay. Okay, all those reds, okay, and all those reds. Those are solutions. How do we express them? How do we express them? Right, we're looking for all the inputs, all of them. We're not leaving anyone out. All of them. All of them. So the solution will have to include all of them. So the solution would be X less than -3 and or. That's right. X is larger than 1. So that's the solution. That's the solution. Okay. I hope that makes sense to you, right? That makes sense to you, right? Still is given the output, right? But this time the output is not given as something we wanted equal to something. Okay, we want all the output to be positive. Now let's look at question number 2. Question number 2. Right? Question number 2, I'm asking for the same thing, but including 0, larger than or equal to 0. So what will be the answer? Well, we're going to have to change it to 2 dots, right? To 2 dots. Right? So this is going to be a dot. And that's going to be a dot. So we want to be positive or 0. So this time the solution will become what? the solution. Okay, so let me put this under, right? So solution for the previous one. And now the solution for this new one, question number 2 would be what? All right, sometimes it just, so the software has a little temperament. Okay. Oh no, okay, sorry. So the solution, okay, the solution would be similar, but including the 2 points, because the output may be 0, right? A positive or 0, right? So this the interpretation, right? So now let me change the dots. I change it 2 dots. Okay, so make it dot, dot, right? But the nature of the question is going to be reinterpreted. It's very similar. Okay, it's knowing the output. So positive or what? Or 0. Positive or 0, right? So this is a positive or 0. So we include the 2 dots. So how do we write down the solution? The solution would be the input, when the input less than or equals to -3, or the input is larger than or equals to 2, equals to 1, and that's when we get output positive or 0. I hope that makes sense. Now, question number 3. Question number 3. What's question number 3? I'm creating question number 3 for you. Question number 3, I want to identify all the input such that the output is negative. Negative, right? So not a positive, but negative. And you got it. I'm sure you got it, right? So which part would be the picture? Which part will be the picture? It will not be these parts, right? So these 2 red will have to be, these 2 red have to be deleted, right? They have to be deleted, right? So that has to be deleted. And where should be the solution? That's right. The solution is going to be in the middle, right? Because we want it to be, we want the output to be negative. Where do we get negative output? Right here. This piece has a negative output, right? Negative outputs. That's what we want. That's what we want. And does not include -3, does not equals to +1. So I'm going to mark that interval, right? And I'm going to make it red and thick. There you go. So that's a solution. How do we describe that solution? That solution is going to be X is going to be greater than -3, less than 1. So that's a solution. What it means is that if you choose any value between -3 and 1, it's guaranteed that your output will be negative. Your output will be negative. And the next question, I think you have guessed it. Okay, this is question number 3, sorry. Question number 4. Question number 4. Okay, I want that to be less than or equal to 0. Less than or equal to 0. What does that mean? It can be equal to 0. So negative or what? Or 0. Negative or 0. So that in that picture, the solution is almost the same, but it will be dots, right? So we're gonna have the dot. We're gonna have the dot. We're gonna have the dot. There you go. And how do you describe these solutions? The solution would be what? The solution would be X, wait, okay, from -3 to 1 inclusive, including -3 and +1. Okay. Right, so we have four more questions, right? So the question, in the case of given input, we know what to do. In the case of given output, we also know what to do, right? So what are the cases of given output? Okay, so let's do a little summary, right? Let's do a little mini summary. Mini summary. So how many cases we have here? Okay. All right. So we have these four questions, right? Question number 1. Solve for, right? We want that to be positive. We want that to be positive. Solve for X such that this is a positive. This is a positive. Okay, so I'm gonna just make it simple. Okay, and the function, the meaning of the function, right? Want that to be positive, and the graph. That's question number 1. That's question number 1. We got the graph, right? So that meaning is clear. And equal, we dealt with equal already, right? So the other one is less than 0, right? So less than 0. Right, so just f of x is less than 0. How about less than equal? Equal to 0, we already did it, right? Equal to 0, we already did it. So that's, okay, equals to 0. So what's the less than case, right? The less than case, right here, right here. Right, what's the equal 0 case? Equal to 0 case. Equal to 0 case, we did it long ago, didn't we? Equal to 0 case. Where did we do equal to 0 case? That was long ago, right here. Equal to 0 case. I think this will be much simpler to understand. Okay, and sometimes you get to greater than or equal to 0, less than or equal to 0. That's it, right? And the solution, the form of solution, if you look at the solutions, right? When it opens up, right, the solution is what? X less than -3 or X is greater than 1. And in this case, -3 less than X less than 1. In this case, X equals to -3 or X equals 1, right? So whether if you have greater than or equal to 0, then you have this case and that case, you get the dot. If you have less than or equal to 0, then you have this case and these two cases, right? And I hope that's clear, right? Output is a given. Output is a given. Output could be given as is 0 or less than 0 or larger than 0. Okay, but next I have 4 more questions for you. I have 4 more questions for you. So this time, this is going to be question number 5. Okay, this question you can see, okay, is asking you, say, solve for x. Oops. Solve for x. Okay, how does it look like? Okay, solve for x, and we have a x squared, sorry, x squared, oops, x squared plus 2x is larger than 3. What do we do? What do we do about it? All right. What we can do is that we're going to work on this function and the output is larger than 3. We certainly can handle it. And the other way is what we can do is that we can make 0. Because you can see all of these questions we have here, right? When you compare the output with 0, it's actually much easier because we have the x-axis and we have the x-axis as the, as a divide, larger than 0, smaller than 0, right? Larger than 0, smaller than 0. So in this case, what we can do a little algebraic transformation, okay? Because if this is true, right? If this is true, what else? And then what? Then what? If we subtract 3 on both sides. So if I subtract 3 on both sides, then it will be larger than 0. Okay. In the former case, you see the nature of the question hasn't changed, right? You want to find x, and the rule of the function is such. Okay, this is the rule of function. The rule of function is that you take the input and produces output, right? We want output to be what? To be larger than 3. Okay, we want the output to be larger than 3. Right, want it to be larger than 3. And in this case, however, we're still looking for input, right? The rule is tweaked a little bit. The rule of the function is tweaked a little bit. Okay, and we want the output to be what? To be larger than 0. You see that? So these two questions are the same question in nature. And besides, we already know the curve for this function, right? So instead of graphing another function, we just use the existing curve. And besides, comparing with 0 is much easier. Okay, so in this case, guess what equation will be, what solution will that be? If we do this transformation, right, from here to there, we basically solve the same question by using our existing result. And also that the making 0, right, when we have an if statement, right, we know the output or something. Making 0 is a very, very important technique. Making 0 is a very, very important technique because greater than 0, less than 0, equal to 0 is much easier to visualize than other cases. Okay, it can be done. You guys can try this, right? But it's just so much easier. It's just so much easier to compare your quantity with 0. So without further ado, right, this is larger than 0. So it's really the same question now. It's really the same question now. So of course, we're going to get the same answer. We're going to get the same answer. Does that make sense? So this is where the algebraic transformation takes place. Okay. And since we have this case, right? That's it. So that's the picture. And of course, you probably guessed it. My question number 6 would be the following, right? My question number 6, I'm going to make it say, oh, I'm going to make it less than 3, right? And then you can tweak it, right? You can tweak it. You can make one side equal 0. Okay, you can make one side equal 0. So this time, you just be solving this inequality instead, and it turned out to be to be this piece, right? It turned out to be this piece, and the solution we already know. The solution is already known. So you can see a lot of the questions. You have more than one way to resolve it. If you understand the nature, if we understand the nature of the question, and the nature of the question is not difficult for us to understand, because after all, we typically deal with a rule, right? A rule which is a function, the rule of function, and input output, right? Sometimes input is given, sometimes output is given. And for the rule itself, we can tweak it. We can tweak it, right? Using our algebraic principles, adding the same number on both sides, subtracting the same number on both sides, making 0, etc., etc. Okay, and of course, if I can get to question number 7, I can say, hey, solve for x for me, but this time I'm going to make it greater than or equal to it. And if you tweak it, right, we ended up solving that inequality, which is greater than or equal to 0, right? I think you already guessed it. You already guessed it, right? What would be the solution? We have done it. We have done it, haven't we? Right? Greater than or equal to 0, right? Greater than or equal to 0, which is right here. Same solution, same solution. You can see how it can be tweaked, right? How it can be tweaked. Last but not least, say I want this to be less than or equal to 0. I want this to be less than or equal to 3. And of course, we understand it's just, if we tweak it algebraically, it's going to be less than or equal to 0. And we have an answer for that too, right? We have an answer by making 0, right? We got this answer. So I'm not doing that all over again. Okay, so now there's one more question that's been left out. One more question left out. Okay, we have the summary. So let's go backward. There's one place. Okay, I said I will come back to. Okay, I give you one method. To find the X-intercept, didn't we? To find the X-intercept, remember that place. Okay, so at the time, I promised that we're going to have more than one method. And what's the other method? Right, we talk about method 1. Method 1 requires you to solve, with have a complete square. But what if you don't have a complete square? Is this the only way to solve it? And the answer is of course not. Of course not, right? Finding the solutions, finding X-intercepts, right? So I'm going to give you method 2. The second method to solve for X-intercept is this, okay? To find X-intercept is using quadratic formula, And also you can use factoring, okay? So if you use a quadratic formula, right? If you use a quadratic formula, you can find that equation, you can find the solution to that equation, right? And that equation has the form of, let me put it in the bracket as a reference, right? The quadratic formula is for this equation, plus bx plus c equals to 0. Okay, where a cannot be 0, we never forget that condition. And the quadratic formula tell us that, I know some of you even know how to sing the songs, right? So negative b plus minus square root b squared minus 4ac. And then we can just use the formula. And then you make the fonts larger so you can see the negative sign clearly. And we have that situation right here, right? So a is 1, right? A is 1, b is 2, c is negative 3, right? So we just plug in the formula. Let's do it, right? So this a equals to 1, b equals to 2, and b is 2, a is 1, c is negative 3. Okay, and you calculate, you get 1, yay. Wait a second, how come we get 1? No, impossible, that cannot be right, right? So I don't trust this software. We don't trust everything software gave us, right? Because I know this is wrong. It cannot be equals to 1. Because we have plus minus, right? We have plus minus. So, right, so we have negative 2 plus minus. What's in the square root? 2 squared minus 4 times negative 3. Negative 4 times negative 3, that's a positive 12. 12 plus 4 is 16. Square root of 16 is what? It's 4, right? So we have 4 here. And we have 2 solutions, right? You can use x sub 1, which is going to be this form, and x sub 2. This is basically a review of algebra, okay? Intermediate algebra, subtracting, and this is a plus. And then you simplify, right? And this one give you negative 3, and the other one give you 1. So you can see that's why when I see it equals give me 1, that cannot be right. It cannot be right. So you still get these 2 x-intercepts. Okay, so this is another way to get the x-intercepts, which is the same as here. So this piece is as a review for intermediate algebra, okay? And we do have a third method, method 3. I just mentioned the third method actually is by factoring. I don't know how good you guys are with factoring, but I know there are a variety of ways of factoring and many teachers teach them differently. And here, I just assume you guys are pretty good with the factoring. So you're gonna get x plus 3 times x minus 1. The question is sometimes the factoring cannot be done so easily. Okay, and in this case, it's happened to be pretty easy to do the factoring. right? And use the principle number 5, we get x plus 3 equals 0. Or x minus 1 equals to 0. And then you get x equals to negative 3. And x, or x equals to 1. Right? So you still get that x-intercept, sorry. You still get x-intercepts. So there's 3 methods, 3 methods. Which one is, is more reliable? Really, it doesn't really matter, because since the advantage of using the complete square one is because you already have the complete square. Okay, it could make your remainder calculation much easier. Method 2 is a method you can always use, and it also tell you a lot more information. It also tell you a lot more information, because along the way, since b squared minus 4ac is positive, which here we have a 16, and we know that we should anticipate 2 x-intercepts. Method 3, sometimes it's just quick and easy. If the factoring turned out to be very easy to do, go factoring. Okay, so there's not a particular personal preference unless, I think it's up to personal preference, okay? However, quadratic formula can always be used. Completing a square can always be used. Factoring can be difficult and it can be very easy. Okay, so it depends on the question. All right, so this lesson we have talked about all of these things, right? We talk about all these different aspects. Okay, so these questions basically teach us how to read the graph, because we know how to make the graph, how to sketch it. So we will focus on those. We'll have our attention to see those. We have those eyes to see the details, to understand the meaning, right? So overall, after all, if you reflect on the questions we have done, I'm going back to this before this example number 1, right? Most of the time, like almost 99% of the time, right, in algebra class, you are dealing with a rule. Okay, the rule can be, of course, a rule function. Sometimes we know the input to find output. Sometimes we know the output to find input. And the rule can be tweaked, right? You can transform one rule to another, like the making zero technique, So the method I'm talking about here can be applied to other situations, okay? And next, before we terminate this lesson, I like to talk about why quadratic is such an important function, right? Why don't I do a lot of those polynomials with power 3, power 4, and so on and so forth? Interestingly, quadratic is a function that we know very, very well. We know it's inside out. Okay? We know when it opens up, when it opens down, how to find Y-intercept, how to find X-intercept. We have formula. And the formula is very simple comparing to power 3, power 4, and so on and so forth. And for this reason, quadratic is very commonly seen as academic questions. In particular, this function can be tweaked into other forms. Look at that, okay? If I replace x by e to the power of x, what will happen? This is a composition of function, right? Then I'm going to get e to the power 2x, e to the power of x. You see, the question is tweaked. If I tweak this question by sine x, and what has this turned into? This is going to turn into sine of x and b times sine of x. There's all kinds of ways you can tweak it. And in the future, we're going to look at these functions in the section, right? We're going to look at these functions, how to solve it from, talking about exponential logarithm function, because we're going to touch exponential function, logarithm function again. Okay, so that will be the third time we do exponential logarithm. And we're going to also talk about how we're going to solve these questions or similar questions. So we will touch trigonometry one more time after quadratic. So you can see that these quadratic functions does have profound influence over academic questions. The reason I say academic questions, they're omnipresent. Quadratic functions are omnipresent. That's why they were covered in elementary algebra, intermediate algebra, and now you're doing pre-calculus, you still see them. Sometimes you see them, and sometimes you don't see them, but they're in disguise. They're in disguise. So, excuse me, of course the graph is going to be different, right? But the ideas of handling them are similar. And sometimes the solutions may be examined because of the specific situation we're in. Okay, I think this lesson is long enough. Okay, take your time, take your time and watch it slowly. Okay, maybe take pause and take breaks. All right, so we've covered all these aspects of quadratic. Okay, we'll have more example to come. And before I let you go, right? Then the question is, how could I tell from the function, right, without having to do the graph, just some simple algebraic manipulation, I can tell whether the curve is crossing x-axis or not. And there's a way to tell. Okay, we're going to continue this conversation, but here I'm going to give you the answer here. For this example one, which we did the whole time, we covered all the aspects of it. For this particular example, we actually can tell it is crossing x-axis by b squared minus 4ac. Okay, b squared minus 4ac. Okay, and this is called discriminant. So what is the form? How do we get those values, right? We just talked about f of x. This is the general form. Okay, this is general form. In this general form, which we have here, right, we can identify that A is 1, B is 2, C is -3. So all we have to do is just to plug in, right, the 2 squared minus 4 times A times C, which is -3, and we got a positive number. If b squared minus 4ac is a positive, then we know the parabola crosses the x-axis twice, okay? i.e., there are 2 X-intercepts. There are 2 X-intercepts. Okay. All right. How about other cases? What if the discriminant, right? So there are 3 cases. There are three cases. Okay, the first case, so today we just did if the discriminant is positive, right? The parabola crosses the x-axis twice. The second case is D is 0. The parabola is going to cross the x-axis once, and there is one x-intercept, okay, no plural. And last, if D is less than 0, the parabola crosses the axis at no time, okay? So we say does not cross x-axis, i.e. there's no x-intercepts. Okay, there's no x-intercept. We can use single, right? We can use singular. But anyway, so this is the summary, and we just discussed the first case. Okay. So without further ado, and until next time, thank you for watching.